So let's say you found a skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey everybody, welcome to Dapper Reacts number 67, Dinosaur Bone Carbon. I am joined today by both Dr. Dino, as I have been for most of the series, or I think all of it, and also today by John Baker, who in fact does radiometric dating as part of his day job, which is the reason that I was like, hey, this seems like it might be right up your alley. So you guys are unmuted on my end. If you unmute on your end, they can hear you. So, John, you want to introduce yourself to everyone real quick?
Sure. I've been around before, but I'm a geologist by training. I focused on geochemistry of sedimentary rocks for my master's, went on to study paleoclimatology as a PhD student, and that's what I've been doing ever since.
All right. So Doc, do you want to quick introduce yourself again?
Sure. Howdy there, folks. I'm Dr. Dino, not an actual doctor, yet at least. I have a bachelor's in geology, focusing on... What was that?
Not being a real doctor while calling yourself Dr. Dino is kind of part of the shtick.
Yeah, true. Anyway, I have a bachelor's in geology, focusing on paleontology, and I am currently looking for more work as a fossil preparer. Hopefully
Awesome.
Somewhere that'll pay me.
That would be ideal, right? Okay, so let me take a look. We got a couple things. Ben Deplorable Ilk Thick Tunicate B2022 for 10 pounds says something. But first, I want to point out the Gunter Beckley blog post on evolutionnews.com that used to be calling me and Professor Dave and Aaron Ra and Jackson Wheat and Gutsa Gibbon and putting us and saying and their deplorable ilk. That and their deplorable ilk has been removed now, so that's fun. But anyway, Ben Deplorable Ilk Thick Tunicate B2022 says, let us all celebrate the one universal truth that all right-minded people can agree on, irrespective of their opinions on politics, religion, gender, etc. That AIG are an Agbe of Ixday. In fact, they are, and I will take a drink to cheers on that one. Yes, we are doing the drinking rules, but no, we're not going to go through the drinking rules. You'll either pick them up now, or you can watch on Tuesday, where we describe them every single time. Let's see. Vegar says, same Gorgon, new name, and Vegar has been a... Or is it Vegar? I think it's Vegar. Has been a member for 8 months at the tetrapod level, so thank you very much. Alright, so we are here to talk about Dr. Thomas Kindell. Now, he does, from what I can tell, have a legitimate degree from a legitimate university. However, it is not an irrelevant field. It is basically a degree in Christian theology. Which, hey, you know what? There's a lot of Christian theology out there, and someone needs to know all about it. So, that's great. However, much as it's interesting that he could write a big, long dissertation with various kinds of Christian theology, and much as that might be interesting to me, because you guys might not know this, but I know all sorts of weird stuff, and Christian theology is one of those things. It's not dinosaurs. It's not paleontology. It's not geology. It's not atomic physics. All of which are things that are relevant to what he's talking about today, and none of which is he an expert on. So, yeah, we'll see how that goes. Unless either Doc or John have anything to add, I'm gonna just bring Dr. Kindell, or Kindle, I'm not really sure, in. So, here we go.
Sounds good. I'm excited to see.
Oh, I haven't.
One of the worst.
Oh, and we forgot, there was one drink for Dapper's Professional earlier for me screwing up the intro. And then also, former Deplorable Ilk Thick Tunicate B2022 gifted 5 Dapper Dinosaur memberships. Then went to Queen Necro 2, Deplorable Elk Nanovirus, Dendnik, that's I think, Christopher Tablante, I think, maybe, and Eric Davis. We'll take 5 drinks for that real quick. Here we go. 1, 2, 3, 4, and 5. There we go.
Things. In conclusion, is the finding of carbon-14. Remember, carbon-14, unlike uranium-238 and things like that, other radioisotopes, it has a very short half-life, and it doesn't decay by the alpha decay, but by the beta decay process. It disappears.
I mean, he is right that it is shorter than many of the other, or shorter half-life than many of the isotopes used for radiometric dating, and it doesn't decay by alpha decay, so good job, guy. You got the basics right there, so we'll take a drink for that.
But he did say it disappears. It's always replenished. I'm going to keep that in mind.
Well, I'm
Sure, it disappears.
I'm hoping that he adds some context to that to contextualize that, because like he might be saying that carbon-14 simply vanishes into thin air, which isn't true. It goes back to nitrogen-14. He might be saying,
I think you're setting the bar kind of high here.
That's true.
Yeah, a lot of creationists don't seem to understand that it gets replenished, or if they do, they misrepresent it.
Well, we'll see what happens.
Yeah,
After
we'll
a
take bets.
little more than 10 half-lives, which means you get a little over 100,000 years.
Oh,
Can't even
okay.
detect any left. Theoretically, if you get to 250,000 years, there won't be a single atom of carbon-14 that has not decayed back into nitrogen-14.
That's not how half-lives work. So, for those of you who might not know, a half-life means that after a certain set amount of time, on average, half of the sample will no longer be what the original substance was, right? So for carbon-14, if you had a kilogram of carbon-14, after one half-life, 1/2 kilogram would be carbon-14. The other half would be the nitrogen-14, because the difference in weight between those two is pretty minuscule, so it would still probably be about a kilogram or so. But the thing is, if you graph out that 1 half-life, half is left, 2 half-lives, a quarter is left, 3 half-lives, an eighth, right? Where does the denominator become infinity, which is really what you would need for it to essentially be no carbon? Never. And so, is there a point at which, after a given amount of finite time, a finite amount of carbon-14 will all be gone? Yeah, probably eventually, but you can't actually say when that will be, because it's fundamentally a stochastic process. If you look at a single atom of carbon-14, right, you don't know when that atom will decay. It could be now, it could be 14 billion years from now. All you know is that in a certain amount of time, which is the half-life, it has a 50-50 chance of decaying. But if it doesn't decay after that point, what's the chance that it will decay in the next half-life? Still 50-50, right? So, this is a fundamental misunderstanding of how this works. Now, it is true that after about 10 half-lives, any reasonably sized sample is going to be hard to detect anything left, right? And there might not be anything left. But you cannot make a simple blanket statement that after 10 half-lives, things are gone. Because I promise you, the number 2 to the 11th is a real number that's not infinite. So, Pibblepunk, half dog, half canine, who's been a member for 11 months, is at the tetrapod level, says, I literally just woke up. Let's go with a Godzilla, and I will take a drink for that. Thank you very much. So, yeah, I just hate this sort of like weird misunderstanding of the very concept of a half-life that a lot of creationists seem to have. I also talked to one once who thought that everything would be gone after 2 half-lives. Because after 1 half-life, the first half decays, and then after the second half-life, the second half decays. And it's like, no, it's not linear. That's why we don't just have a per unit time with a simple linear relationship.
Well, I think what he's doing here is setting up. He wants to convince you that after X amount of time, there's not a single atom left. We shouldn't detect anything, and I can really see where this is going to lead. The problem is, it's not that nothing's left after 75,000 years or 100,000 years or however many half-lives. Like, it just gets so far below the detection limit that you don't know the difference between that and actual noise. And we'll probably get straight back into this.
Yeah, probably.
It's worth covering just how we measure this in the first place. And once we get to that point, all this discussion, I'm sure, is going to be kind of worth.
Got a couple things.
Go
ahead.
Oh, sorry. I was just going to say a helpful analogy that helped me figure all this out when I was first learning. A half-life is like taking a bite out of a cookie. The first bite, you take half of it. The next bite, you take half of what's left. And you just keep going until you're just left with tiny crumbs. Can't really measure them.
Yeah. Naranda puts, who's been a member for 8 months and is at the tetrapod level, says, you can't carbon date that there's no carbon in it. I mean, basically, that is one of the reasons why largely can't date per mineralized fossils is they're not made of the same stuff that still has the carbon in it. But there will actually probably be carbon in there. Carbon is a very ubiquitous atom all over the Earth's crust, and technically there will be carbon there. Roasting a Cold Bones Keller for $4.99 says, "Will the last atom of carbon-14 ever decay? How do you get half of one atom?" So you got to remember that this is a fundamentally both quantum and statistical thing. Which, I mean, if it's not statistical, it probably wouldn't be quantum. So yes, eventually the universe will run out of carbon-14, right? Probably trillions of years in the future, maybe more. There will eventually be a time when the last atom of carbon-14 that ever will exist is going to decay. And basically, like I said, if you were to be able to watch a single atom of carbon-14, every half-life it would have a 50-50 chance of decaying back to nitrogen-14. Eventually that'll happen, right? Eventually. How soon will it happen? I don't know. There's no way to tell. All you can do is put a chance on how likely it is that it will have decayed after a certain amount of time. Now, after a very, very long time, that chance will be so close to 1 as to make really no difference, right? So if I said, hey, will this carbon-14 atom still be here after 1 trillion years? I mean, no, probably not. Can I say that with 100% surety? Also, no. But if I were to be able to time travel 1 trillion years into the future to watch that carbon-14 atom and then report back, would I place a money that it would be gone? Yeah, I would place a lot of money that it would be gone by that point. So, yeah. All right, here we go.
Just simply should not exist. We find it all over the place. Now, how does it work?
Oh, by the way, sometimes his video pauses. That's a problem with his video. It's not your internet connection or like StreamYard or my OBS or something. That was in the original video, is that every once in a while his video feed just pauses and the audio keeps going. So if you find yourself wondering what's up there, that's what's up.
Cosmic rays bombard the upper atmosphere, and what they impact is nitrogen-14. The collision produces the radioisotope carbon-14.
Hey, he's getting it right.
Okay.
Take a drink.
Now, carbon-14, like ordinary carbon-12, combines with oxygen to produce carbon dioxide, except this is not carbon-12 dioxide, it's carbon-14 dioxide, which is used by plants in photosynthesis. So plants absorb it, animals eat plants, so they get it into them, and since animals feed on vegetation, it is added to their bodies at present at a ratio of about 1 to 1 trillion. So in other words, for every ordinary carbon-12 atom in the environment, there's only 1 atom of carbon-14. So it's a very small ratio, trillion to 1.
I actually don't know. Is that ratio roughly accurate?
Yes.
Okay. All right. It's just I've never bothered to keep that number in my mind. So
It's actually even less than what he's putting, I believe. I have to double check it, but I think it's closer to the 10 to the 12th, like 1 to 10 to the 12th kind of ratio. So it's extremely rare. It's good to keep in mind. It's funny, earlier you get that example of like 1 kilogram of 14C. Like the amount of radiocarbon that's produced every year in the atmosphere globally is about 6.5 kilograms.
Well, I was using it for simple math. So.
No, it's funny because it's actually close. Like it's 1/6 the amount that's produced in the entire globe every year.
Yeah.
Just to give you an idea of how little there is in the atmosphere. So that's the problem with radiocarbon, and that's why we avoid it in a lot of scenarios. It's very difficult to detect, and it's everywhere. He said we find it everywhere, but that's the thing. You're going to find it everywhere because it is everywhere. This is one of the reasons that uranium lead dating was so difficult. Well, it is even now difficult, but in the mid-20th century, when they're developing it, it's almost impossible to do because there's so much environmental lead. Right?
Yeah.
And you have to isolate the system. So you've got lead coming into your analysis. You can't completely isolate your sample from the environment. And we have in the atmosphere, as it turns out, a lot of carbon, and there's a decent amount of radiocarbon in the atmosphere. So it is impossible. It's not difficult. It's impossible to separate all environmental radiocarbon from your sample, whatever you're analyzing. That's why every single sample that you try to date by the radiocarbon will give you a finite age. You will never ever give you this infinite age. You will never find 0 radiocarbon in a sample because there's always some environmental radiocarbon that's introduced during the preparation, during the analysis, and so forth.
Yeah, and I mean, I have some personal experience measuring radiation levels as part of like radiation control, right? because that's one of the things I did in the Navy, was I made sure that the radiation from the nuclear reactor stayed mostly inside the reactor compartment and didn't do stuff outside of the reactor compartment, which, would be a radiological event. And yeah, I mean, we would always detect radiation, but the problem is it radiation above the background, or is it just what we're always going to get no matter what? Because there's radioactivity everywhere. It is literally everywhere. You walk outside, radiation. You go inside, radiation. You stand in Grand Central Station, more radiation than typical, actually. Because it's made of granite, which itself actually is fairly radioactive compared to most other rocks that are just kind of hanging out there. I've got a couple things to read here. Skeletor, over 9,000, who's been a member for 17 months and is at the amnio level, says, how long does it take for half an AIG to decay into another creationist organization? We actually have an answer for that, because it did happen. The CMI AIG split, all you had to do was look for the founding of AIG, and then look for when Ken Ham split off the American version of AIG, and then the rest of AIG turned into CMI. That is how long the half-life of an AIG is. Roasting the Cold Bones Keller for 499 says, how much carbon-14 is produced underground from uranium, and others, per year? Uranium at FAM. I don't know. I would imagine it's fairly small, but not zero.
It is small. Go ahead.
Oh, well, it's enough to be picked up in core samples, no matter how far you go down.
Okay. And John, what were you going to say too?
It is a small amount, and depending on the concentration of various elements, it's not just the uranium, but also you need things like nitrogen that would capture this radiation coming off of from other decay products. But it can be high enough to give you apparent ages of 50, 60, 70,000 years easily.
Yeah. All right, there we go.
However, that does decrease. After death, this ratio will slowly decrease, since while carbon-14 continues to decay, it is not replenished by feeding. The amount of carbon-14 in a dead animal shows how long it has been dead if, that's the $64 million question, if one can be sure of the amount of carbon-14 in it when it died. That's why, even though we find carbon-14 in dinosaur bones, all the ones we've ever tested, it's in there. Ancient coal, hundreds of millions of years old. Ancient wood, hundreds of millions of years old, they claim. Plenty of carbon-14 in there, very measurable. But they end up dating it to usually be in the range of about 20 to 45,000 years. Pretty much in those parameters. Why? Because their starting assumption is different.
One thing I want to point out is this guy is a young Earth creationist. So a radiocarbon date that's accurate, that's like 30,000 years, is just as devastating as a, uranium lead date for something of like 200 million years. There's no real difference to him, right? Either way, it's orders of magnitude older than he thinks the Earth is. And so it's always weird to me that creationists don't seem to be like too concerned about radiometric dating, and instead just point out, well, look, if we take these assumptions naively, then it seems to indicate that dinosaur bones are younger than you thought. It's like, okay, let's just accept that.
Yeah, I liked how we skipped over another thing where they would stress very frequently the various assumptions they think that we make blindly, which of course we don't. But notice how he said, well, it stops accumulating in the organism because it stops eating. And although generally that's true, it's not true in the absolute sense. Like we assume in terms of the model, the math here, we assume that the system is closed, right? There's no carbon coming in and out of the system, right? Because if there is, then your date could be wrong. If you have a source of carbon that has a different radiocarbon ratio in it, or radiocarbon activity in it. So if you have a sample that's been there for 5,000 years, and then you're adding things like water in the ground, which, that carries carbon dioxide in it, it can carry pieces of organic matter in it, whether acids or any kind of organic material that's in that water can bond or mineralize or something else to your fossil. In fact, that's the process of fossilization, is the replacement, especially of minerals like carbonates, with modern or fresher sources of carbon, right? And so you don't have a completely closed system for most cases. That's why we're careful to date the things that we do. If you want to date a fossil that's recent, we want to go date a woolly mammoth. It's potentially young enough to be dated by radiocarbon. If we do that, we are going to avoid certain parts of the fossil that we know are susceptible to being replaced, recrystallized, or contaminated. Other parts will, like the collagen, are a lot more robust and resistant to that sort of thing. So we'll date specifically that. But it's simply false to say we assume that it stops accumulating radiocarbon when there are quite a few sources of more recent carbon that can alter this.
I mean, even just exposure to the atmosphere could do it too. Like there is carbon-14 in the atmosphere, just like how a bar of aluminum or iron will form an atom's thick layer of oxide on the outside. So will fossils.
Yeah, and I have to be careful here because I don't want to make it sound like this is completely a shot in the dark and unreliable. But if you know what you're doing, if you're familiar with the carbon system and your basic organic chemistry, this is extremely successful. The best examples of that would be to look at tree ring studies and varved lake studies where they date a series of tree rings where each one should be older than the next, or a series of layers in a lake sediment, where you know that every layer has to be older than the previous one. And that's exactly what we find. I work with speleothems, cave samples, and we can use radiocarbon dating and on these, not necessarily to give us the age of the sample, but it's a complicated question. But still, we find the radiocarbon age increases with depth every time, and that's consistent with the independent methods that we use to date these materials. And this works just fine as long as you are careful to sample the right things. And I don't want to give anything away, but in this case, they are not careful to sample what you should be sampling. It's not if you want to know the age of the organism. I mean, it will give you a result, and it could be an interesting result, but it has nothing to do with the age of the organism.
We believe God created the earth between 6,000 and 7,000 years ago, according to biblical chronology. We have plenty of proof from rapid decay of the Earth's magnetic field, which has been tracked longer than any other global geophysical phenomenon in the history of science.
I was on mute. I'll take a drink for that. Okay, so starting back over there. Sorry about that. I put myself on mute to type a little bit because there was a question in the chat and I don't want it to come through on your end. Sorry about that, everybody. Anyway, we took 2 drinks there. One for me being a professional and one for that being stupid. So where was I? Right, geomagnetism. So we have been tracking the strength of the Earth's magnetic field for a bit over a century, and it has been decaying in a way that you could fit to a geometric decay rate. Which, okay, yeah, that's true. But there's this thing called geomagnetism. When rocks form from magma or lava, the magnetic components in that rock will align themselves to the local magnetic field because they're magnetic. It's basically the same thing, the same reason a compass works, right? Now, the degree to which, the strength with which they align themselves is proportional to the strength of the magnetic field, right? Because that's just more force on them. And the direction in which they align themselves indicates the directionality of that field. And so when you look at things like different rock sections from like in the Atlantic, where we know that there's a mid-Atlantic ridge spreading the Atlantic wider and wider, which on the other side of the globe is making the Pacific narrower and narrower, you can check. You keep careful track which way your samples are facing, right? Which is the north direction and south direction when you take the sample. You can check how strongly aligned are the magnetic components of that rock, and in which direction are they aligned. Because once the rock cools, they can't then easily switch, right? It's like your compass points north pretty reliably when you're just using it, but if you were to put your finger on the needle and then swing your compass around, the needle's not going to go anywhere because you're holding it in place. Same thing happens with the magnetic components in these rocks. And so when we check these, what we actually find is that the Earth's magnetic field strength and its directionality goes back and forth from time to time. It does not have a nice, smooth decay. And you would have to argue some kind of very new physics in order to get that rock to fit an exponential decay. And so this is one of those things where creationists will complain vociferously about scientists making these assumptions that, like, spontaneous nuclear decay always had the same rate, even though we don't know of any physical possibility that could realistically change that, because it's a fundamentally nuclear physics kind of thing. It's, you know, controlled by, like, the strong and weak forces, which, like, how are you going to vary those inside the nucleus of a uranium atom? I don't even know how you could. Like, you heat it up. That doesn't affect the strong or weak nuclear force. Doesn't matter. It affects the electrons, I'll grant you that, and it means the atom moves around a bit, but, like, it's not going to affect the strong or weak nuclear force. And so they'll complain about that, but then they'll have this, where we know it doesn't stay the same. We know it has changed. We've measured it changing. And they'll say, yeah, you can just extrapolate this all the way back. We get the same thing with, like, salt accumulation in the oceans, right? They'll say, well, at the current rate of salt accumulation, the Earth couldn't be any older than this. Well, yeah, at current rates, we know those don't work. We know they've changed.
Especially because the oceans are freshening at the present.
Well, I actually didn't know that. I'll have to get into that. We got a couple things real quick. Pibblepunk, half dog, half canine for $5. Oh, no, earlier we got Rosina Keller. Rosina Coldbones Keller says, I just love how young Earth creationists start as if they're talking about radiometric dating, but then pivot to only carbon dating. Yeah, they do like to just pretend that any challenges for carbon dating are just challenges for radiometric dating as a whole, which is not how that works. Pibblepunk, half dog, half canine for $5 says, do freshly cool volcanic rocks not already contain some daughter isotopes? If not, why not? Google is not giving me any helpful answers here. I want to read the April Van Ryn one, and then I'm going to go back to yours, Pibblepunk. April Van Ryn, who's been a member for 14 months and is at the tetrapod level, says, read in the Tombstone Herald Times that read in the Tombstone Herald Times that AIG is a bag of dicks. We'll take a drink for that. As for the volcanic rocks containing some daughter isotopes, the answer there is it kind of depends, right? So, for instance, when a zircon is forming, there's a certain amount of lead uptake that is likely in that crystal versus other types of minerals, right? So different minerals have different affinities to uptake various daughter isotopes. One daughter isotope that's very hard for any crystal to take up is argon, because being a noble gas, it doesn't form any kind of chemical bonds normally. So that's usually excluded from most crystal formation processes that aren't very, very rapid, because if it's rapid enough, then the argon could just be physically trapped in a bubble. But if it's slow enough, then outgassing is more likely to occur, and you're very unlikely to get much there. But then again, why am I talking about this? I literally brought on a guest to talk about this, John.
Yes. The short answer is yes. In almost all cases, there's always a non-zero amount of the daughter product that is incorporated, which is why, the simple radiometric dating formula that you would learn in like a basic physics class or math class, this is good, but it's not like we just stop there. We always modify that to take into account changes in the daughter product. And then we look for independent methods that we use to estimate the amount of initial daughter product present, right? So almost always we're looking at some kind of isochron method. Like the argon-argon method is an isochron method that determines not only it determines the age, but it uses an isochron to determine how much your initial argon content was. Same with the uranium lead. All the uranium lead systems, it's always using multiple isotope systems to determine how much common lead was present. Like you said, in something like a zircon, that the amount of lead present in a zircon at the beginning is very, very close to zero, but it's not exactly zero, and it's enough that it can throw off your age by, 0.1% or something. So it's worth correcting for if you're a stickler for precision, but it's these are typically not things that have massive effects on the age, that assumption, and we always have independent ways to check.
So I have a follow-on question there. Are you aware of any, like, large-scale problem with initial daughter products present in a sample that could allow for the samples with their measured ages as they are now, which stretch into the hundreds of millions or even sometimes billions of years, it would be enough of a problem to bring them down to the level of 6,000 to 10,000 years?
No, definitely not.
Okay. Because that's one of the things, is that's what young Earth creations would need. We would need it to say, like, oh, hey, you think you have like 500 million year old basalt? 6,000 year old basalt, baby. Like, you're gonna need a whole lot of daughter product to make that happen, like a whole lot.
Mm-hmm.
It's decaying rapidly, exponentially, with a half-life of about 1,400 years, which means back just several thousand years ago, at the time of the flood, and before the flood, it was several times more powerful than it is today. Why is that?
It's the magnetic field he's talking about. And no, it doesn't mean that. We can check, and we know that that's not what
I
happened.
did want to add into that very, very quickly. I mean, you mentioned the geomagnetic methods to reconstruct Earth's magnetic fields. On top of that, we do have like archaeological methods that, in case anybody may be skeptical of like going back millions of years using the the ocean crust and things like that. We use pottery, for example, that is dated historically to do the same thing. And we know 2,000 years ago or 4,000 years ago, Earth's magnetic field was not stronger than today. It was pretty close or weaker, very, very slightly than today.
Basically,
if I may, there have been some fabulous dating methods applied to Pompeii material. And there's been enough radiometric decay that we can get accurate readings for stuff from the Pompeii eruption now. Mm-hmm. It's pretty neat.
In fact, actually, the Pompeii eruption was dated using radiometric dating to the calendar year that is reported by Pliny the Younger, who is our biggest source as like an eyewitness of the eruption of Mount Vesuvius. And he recorded a specific year. And granted, our year numbering system is different, but you can convert between them. That's a thing that's possible. And yeah, we've got it to the calendar year. So we know that once...
By two different methods.
Yeah, so once something actually is old enough, these techniques do actually work accurately. One of the things creationists love to do is either use the wrong techniques or date things that are so young that we couldn't possibly get accurate results yet.
Like Mount St. Helens.
Because it's very effective at causing cosmic rays to deflect off of that magnetic field. Some still get through, so you still get carbon-14.
That's only true for charged particles. Are the cosmic rays that are doing this? Yeah, I guess they would be.
So the other way that we reconstruct the magnetic field, by the way, is to look at cosmogenic isotopes such as 14C and 10 beryllium that show up in the atmosphere that gets locked in things like bubbles trapped in the ice core. So we measure gases in the polar ice cores to reconstruct this. We can also use, atmospheric radiocarbon. This is what we get from the calibration curve, but still, fluxes in atmospheric radiocarbon are related to changes both in solar output, the sun's strength, and also the magnetic field strength, which deflects some of that energy.
That is actually one of the things I want to point out, is that this isn't some new thing that the creationists are proposing that no one has thought of, right? The whole reason there's a calibration curve is because everyone who's in this field knows this already.
We've already thought about this before, long before we were born. This is already being done in the 1950s. Work on, how to calibrate this, how to account for fluctuations in both solar luminosity and magnetic field strength. And can we play a betting game? I think he's going to start talking about changes in magnetic fields, and maybe the Earth's stronger magnetic field is going to reduce the amount of radiocarbon in the atmosphere at that time. So we, stupid secular scientists, are going to assume that it was similar to today's atmosphere, when in fact it was much, much lower, giving everything that formed during or around the flood an apparent age of tens of thousands of years.
I think that that's a very likely thing, and when it happens, we'll take a drink, because that's a confirmed prediction, if it happens.
If it happens. And then we'll point out the contradiction in what he just said, because today we observe relatively a lot more than he thinks was in the atmosphere at that time. So if the magnetic field strength was much stronger and has slowly been decaying toward the present day, where does all the radiocarbon in the atmosphere come from? Like, if it was really that low only 4,000 years ago, how do we get all the way up to present levels
production
at this time?
But just several thousand years ago, it wouldn't have been nearly as much carbon-14 produced as it is today.
Here we go.
Today's magnetic field, not being as strong, allows more cosmic rays to produce more carbon-14. So they assume that if you find carbon-14 in a specimen, the only way it could have gotten to a smaller ratio is by decay half-lives. We're saying it started out with less. And when you run that factor, recalibrate the equation, then they'll all come into just about 5,000 years since the time of the flood.
There you go. We'll take a drink.
Okay, so I haven't watched this, I swear. But I should say, as a representative maybe of others in this field, no, we absolutely do not assume that.
Yeah. In fact, the very existence of the calibration curve is only exists because of that. And here's another thing.
Yeah,
you ever seen
assume just the opposite.
Creationists will sometimes do things like they'll pick a population growth rate that will get them from 4,400 years ago to the current population of the Earth, right? And they'll say, well, see, with this population growth rate that's not that different from the modern population growth rate, we can get this. It's like, yeah, but you started with the age that you wanted, and then you tried to pretend that that's a dating method. You're doing this backwards. You have to use the age that you want, or you're trying to measure, as the variable. You didn't, though. You used the growth rate. And here, all he's doing is he's using the production of carbon-14 as the variable, and then he's using a fixed age that he's already determined, and he's just trying to get the production rate to fit into that curve. Because that's the only way to get this to work, right? It's like, yeah, if you work backwards with an assumed answer that you want to get, and you allow things that are actually measurable to just be whatever you want, then sure, you're going to get the number you're looking for. But that's not impressive, it's just dishonest.
I think, to give the complete benefit of the doubt, we can and sometimes do this. Like if we want to know at what rate are concentrations of radiocarbon in the atmosphere for 5,000 years ago, what would they have to be to produce radiocarbon ages that we find today for, I don't know, last glacial or early Pleistocene, late Pleistocene samples? We can come up with that answer. It would have, I've got a spreadsheet open. We can figure it out right now. Like it's going to be, below 1%. But if that's the case, then we could follow it forward. Now you've made a hypothesis, right?
That's the thing. You're using it as a hypothesis.
That it was that much, and it has to go from 1% of modern levels to modern levels over this 5,000 year time span. So what would that do? I mean, what predictions can you make? For example, if you were to radiocarbon date, last glacial to present lake sediments,
it would also
right?
break the correspondence between radiometric dating with carbon and dendrochronology too.
With dendrochronology, with VARV counting, yes, yep. With all the marine cores, all the ice cores, with speleothems and coral records, like all of this would fall apart. Right now, there is a stunning overlap and covariance between ages that we get from radiocarbon versus these other methods. They all fit together, and they fit together with things like Milankovitch cycling, Milankovitch cycles, and forcing of climate that we predict should have happened over these tens of thousands of years, right? So we can make these predictions and then just test them. Like if you want to convince us that 5,000 years ago, those radiocarbon levels were low, and that's why we've dated this stuff to be much older than it actually is, then just test this hypothesis with real paleoclimate data and show that it fits. Mm-hmm. And I say that seriously, but at the same time knowing that it doesn't fit. Like I've gone through this exercise, we could see what happens. The result is you get lake sediments that look like they're accumulating at, say, a few millimeters per year today, but then 4,000 years ago, they would have to be accumulating at 20,000, 20 times or 1,000 times that rate.
Without showing any evidence of higher energy deposition.
Right. I mean, it just leads to absurd results in terms of what the growth rate of sediments and trees and cave formations and ice cores and all of that has to be just to keep up with this.
All right, we got a couple things.
So we know it's all.
We got a couple things to read here. Christopher Kennedy, atheist, who's been a member for 15 months and is at the amniote level, says, creationist Christians can't comprehend complex concepts continuously consuming conical CMI AIG cock carry-alls with a Godzilla, so we will take a drink. Thank you very much. Roasting a Cold Bones Keller for $9.99 says, when young Earth creationists talk about the, quote, decreasing magnetic field, they are talking about one specific metric, the axial dipole component, which started losing strength only in about 1700 after increasing for centuries. Yeah, they're only measuring that. You are right. They are only measuring a specific part of the magnetic field. And we know that it has not been continuous. It's only been doing this for a few hundred years. And it will change again, right? Eventually that won't be the case. Now, how long will it spend doing this decay in the actual dipole component? I don't know. Maybe it'll be doing it for another 100 years. Maybe it'll be doing it for another 200 years. But it won't be forever. All right, we're going to hit play. Let's see what we got here.
The problem, I hope you grasp this, not dickering about its exact ages. The problem is there should not be any carbon-14. After 250,000 years, not one atom. Yet we find it in rich amounts, easily measurable, all up and down the fossil record.
Rich seems like a weasel word there, right? Because there's no definition for what rich is. Because what's actually being found is vanishingly rare, and in some cases, hard to differentiate between just incomplete evacuation of a test chamber, where like not all of the carbon-14 from your previous sample is ever going to be completely evacuated because pumps aren't perfect. And you have to put these things into a vacuum chamber and vaporize them essentially.
Yeah, I mean, that's how you get carbon-14 apparently showing up in diamonds, which I've butted heads with a couple creationists about in the past.
Creationists seem to have way more faith in the strength of vacuum pumps than anyone I've ever met. It's amazing. They must think that the world has just the best vacuum pumps that could even theoretically exist, where you can just get everything down to a complete hard vacuum where there's nothing in the test chamber. It's like, I'm sorry, but no, that's just not true.
Indication all those fossils are just thousands of years old, or they wouldn't have carbon-14 left in them. Now then, excuse me.
You're excused.
Yeah, let's see. Thing to work. There we go. So this is dealing actually with the buildup of carbon-14 after the cleansing effect of the flood. I talk about that in my DVD, Scientific Evidence for Young Age of the Earth. We don't have time to get into that right now.
So, just, graph crimes here. One of the things that I notice, I like that the axes are labeled, right? We've got carbon-14 and time. Good job on labeling your axes. What are the units? I can derive units for time based on the fact that you have a 30,000 year thing here. But what's the concentration of carbon of 14C? What is it? No answer. Just a scale that doesn't actually have any units on it. Put units on your scales, guys. Just label them, put units. That's really not that much to ask. Rosenub, Cold Bones Keller for $4.99 said, there was no carbon-14 in the atmosphere before the ice canopy opened and let the cosmic rays in. Obviously, yes, that is of course how that works.
Well, the funny thing about that is if that were true, I mean, I know it's a joke, but if it were true, then any vegetation or animal life that died in the flood, all of this, I mean, it should have a zero or an infinite radiocarbon age.
Right.
So it means there has to have been, some amount. If we take this at face value.
Oh yeah, because he does have it going to zero at the flood, right? As we go back in time.
Yeah, it can't be zero at the flood. That means all the organisms that died and all the vegetation that made the coal that had to have something in it. Right?
In fact, if that's the case, then these dinosaur bones who died, because according to the basic flood model, dinosaurs are getting buried in about the middle of the flood, towards the late flood. So at least the lower dinosaurs, like the Triassic dinosaurs, they shouldn't be finding this carbon-14 that he's on about, because they would be at the point where, like, carbon-14 creation has only just started, and they're not eating a whole lot if they're in the middle of the flood, right? If there's anything in their guts, it would have been pre-flood material, what's happening right now?
Okay, there are two obvious problems, though, with what this graph, and but the first is that it goes to zero, and it can't have been zero prior to the flood. Otherwise, all that stuff should have zero, like infinite radiocarbon ages. They would predict the same as any other geologist would predict. Right. The second, look at this curve going up, and do you notice how they have the crucifixion like along that curve? They plotted it in time,
which is it's a choice, yeah.
But think about this: like, if that were the case, if we had radiocarbon building up in the atmosphere and it's almost halfway built up 2,000 years ago, that means that any artifact from then should give a false age, not of 2,000 years old, but about 7,000 years old.
Yeah, that's a good point. But creationists love to accept 2,000-year-old carbon dates because it shows that.
What about Dead Sea Scrolls, for example?
Yeah. And that's the thing. They love those carbon dates because they're like, look how old our biblical manuscripts are. To which, I mean, yeah, they are. I'm not going to argue with that. You have very old biblical manuscripts. But yeah. If this is all just made up nonsense, they should be dating far, far older.
So that means that this just absolutely doesn't work. It completely contradicts. Unless you want to say that events that happened 2,000 years ago weren't actually 2,000 years ago. They had to be.
The crucifixion was actually 500 years ago, guys. Just letting you know.
So that would shift these ages and completely. In other words, like the modern radiocarbon levels had to have been met. As far back as you think radiocarbon is reliable, and most people I know would accept ages for like stuff happening around the crucifixion or the early like the Davidic kingdom era.
Yeah, they actually would like to push it at least back to that, because a lot of the archaeology that we have that mentions things like the House of David and a temple in Jerusalem and things like that are in things that are like 3,000+ years. So it's going to go back even farther. So yeah, that is one of the big problems, because they really do like the biblical archaeology stuff that supports the historicity of certain parts of the Bible, which there is, right? Like, there was probably a guy named David who was in charge of an Israelite tribal confederation, who is the basis of the King David stories. We know that there were temples in Jerusalem. We know that there was a spreading pork taboo throughout what we now think of as Israel and Palestine. Like, we know these things, and the reason that we can date them to times that are biblically relevant is in many cases carbon-14, backed up by other things. Yeah. But yeah, that's a really good point. Lieutenant Professor Savage Cobra for $5 says they're eating in between neatly laying eggs while fleeing for their lives. Yeah, that's another thing, is the nice, neat dinosaur nest that you find in the fossil record, and it's like, how did that happen during a raging year-long flood, my guy? What's going on?
Especially when the nests are made up of what they would consider to be flood sediments.
Right. Yeah. How did this nest get dug, laid, and then covered by more flood sediments in the middle of a flood? I don't know. I did hear once there was a somewhat linear nest where there were paired eggs going in a line, and I think it was like 6 pairs or so. And the explanation from Carl Raw was that this dinosaur must have been running as it laid its eggs. That's why they're in a line. I'm sorry, it was laying them 2 at a time? At the same time, in a row, neatly stacked as it was running? Like, my guy.
I mean, like, for a specific fossil example, I have never heard a creationist honestly tangle with, like, the fighting dinosaurs from Mongolia.
Yeah. I mean, plus,
like,
they're in Aeolian sandstone.
Those aren't Aeolian sand dunes.
Exactly, yeah. They're all indications to the contrary. That wasn't windborne sand. Like, oh, okay.
Just looks
like
I
want to point out, from the time of creation to the time of the flood, according to biblical chronology, there was about 1,656 years. And during that time, the Earth's magnetic field was much stronger. Therefore, animals were getting carbon-14 into them, but not at the same ratio that we have today.
Not according to your graph, my guy. I'm just going to take it.
You put units on there, right?
Even he doesn't like his own graph.
Yeah, so to my knowledge, they would accept, in general, the dates of historical and archaeological events, at least going back to, let's say, like the Akkadian Empire, the Mesopotamian era, like the stuff going back to around 2000 BC, 2500 BC, almost, right? At least back to 2000, I would say. And so if you're going to accept this, like back to 4000, that means you've got only like 500 years maybe 1,000, certainly less, for all of this radiocarbon to build up.
Yeah, and also to reach an equilibrium somehow.
And reach a new equilibrium, which is, I don't think that's possible. I'm almost certain it's not possible. Like if you were to just do a mass balance model of how fast this could potentially accumulate in the atmosphere, and you would need for it to accumulate at these rates, like you'd need the magnetic field to be a lot weaker than it is today, or the solar luminosity to be higher. We know that's neither is the case. Like it just absolutely doesn't work. And again, it would, I said this backwards earlier, but it would lead to us misinterpreting the depositional rates of marine cores, of lake sediments and all that to be, orders of magnitude lower or slower than it actually is, right? So it's just an absurd, it leads to absurdity. Like we can make an argument, like a reduction to absurdity argument here that none of this
just doesn't work
at all. Mm-hmm.
Therefore, those buried in the flood would definitely have carbon-14 in them, but at smaller amounts than animals that die today. And you have to take that into account, but the point is there shouldn't be any there. And yet when we test it, every sample of coal, oil, wood, or bone that has been tested for carbon-14 content, even if retrieved from rocks supposedly millions of years old, always contains a measurable amount of carbon-14.
So one thing is, my understanding is that if you test an empty chamber for carbon-14, you will get a non-zero answer back from that.
Yeah, I wanted to give an example or analogy from this. And let's say that my job is I have this fancy machine that can weigh things up to a kilogram. It's an extremely sensitive instrument. Like it'll give you precision down to the microgram. Okay, and so I'll invite you to come weigh your samples on my machine. Right, and I mean, you've both been around labs before, and you weigh things on a scale. What's the first thing you want to do when you weigh your sample on a scale?
You want to zero that scale.
You want to tear the scale. Okay, yeah. So the problem with my scale is you can't see the scale. So when you tear the scale, you don't actually know if there's anything on it already. And in a sense, that's how radiocarbon works. That's how a lot of these instrumentation work. Like you use reference standards to figure out what zero looks like. That's how any scale works. The nice thing about a scale is you can visibly see like there's nothing else on the plate. But if you didn't know if there's anything there, if it were hidden behind a curtain, that could be tricky. Like you have to think of creative ways to find out what zero would, 0 kilograms would actually look like or give you. So you might have to take samples of known weight, put them on the scale, and when it's reading, it actually reads 1 gram, and we know this is 1 gram, then we know that scale is properly teared. And so when we're working with mass spectrometers, especially the accelerator mass spectrometer that we use for modern radiocarbon analysis, and it's an extremely sensitive piece of equipment, but there's no possible way to tear the scale in the truest sense. The only way to do that is to put a sample where you are confident this has no radiocarbon in it, but you've never been able to measure how much radiocarbon it has in it, right?
How would you get
so
that?
That's why we use things. Yeah, that's how we use things like diamonds, which there's really no mechanism to get radiocarbon into a diamond, and so we have every reason to believe that it should be 0, right? We also use old samples. You technically want to use something that has the same composition of your unknown sample that you're trying to look at. And so if you are measuring, say, a carbonate mineral, then you would take a piece of limestone that's 500 million years old and radiocarbon date that and say, that's what 0 looks like. So we'll compare this 0 age, which reads this much radiocarbon, and we'll call that 0. And when we put our sample on there, we compare it against the 0 radiocarbon sample. Yeah. So what he's saying is like, yeah, we always get a measurable amount of radiocarbon. I mean, that's just complete nonsense. We don't know if that's radiocarbon because with every piece of instrumentation, every mass spectrometer, you always have this background level coming in. That is a combination of all sorts of things. And some of that has nothing to do with radiocarbon or any kind of carbon being present. It has to do with electrical noise. It has to do with the ultra sensitivity and super high resistance in your your cups, the detector cups. I mean, you're not measuring a weight when you say like, what's the radiocarbon ratio? What's the uranium, 238 uranium to this ratio? What you're measuring are voltages across a resistor, right? You're accumulating charged particles on one side, and that creates a voltage from one side to the other, which means you have to compete with interferences like electrical pulses in the building or just around. Like, it happens. So you could never get an absolute zero measurement. That's the real challenge to this, and fundamentally what means everything. Fundamentally, the reason that everything he's saying here is going to be a flat lie, that only makes sense if you have never had any experience close to mass spectrometry, let alone radiometric dating methods.
It seems like, on the one hand, this guy thinks of scientists as just complete morons who've never thought about things like variation in the levels of production of carbon-14 or any of these other possibilities. But on the other hand, they're also so competent that they can make 100% precise, absolutely no error, no noise in the signal instruments that will always give you the objective, exact reality down to the quantum level for exactly how much of any substance is in them. And it's like, I don't see how you hold both of those ideas in your head at the same time, because either scientists are giant buffoons who would then you expect make clownish measurement instruments that only kind of work, or if they're capable of making these amazing instruments that give you this god-tier level of understanding of what's in the sample, then why are they also so dumb as to not figure this out? I think, and I think most of my audience would agree, and I hope my panelists would agree, was that scientists are generally pretty smart people who are limited by just, reality. And therefore can't do anything perfectly, because reality isn't perfect. I don't know. That seems like the reasonable middle ground to go with.
Maybe it's Schrodinger's competence.
Yeah.
They can do science until they can't, and then we know better.
Yeah. We got $2 from My Unfinished Journey, who says, I would have done my usual promotion earlier, but that's okay. Let's see. We got Pillowpunk, Half Dog, Half Canine for $10 saying, science only works when it gives the results you want. That's how the flirts can know for certain there's definitely no 15 degree per hour rotation happening. No, don't look at that gyroscope. Oh, man. John and Doc, are you aware of the 15 degree per hour rotation that the flat earthers got out of their gyroscope?
Yep.
I think so.
Pretty funny.
It was pretty great. They spent tens of thousands of dollars on this fancy gyroscope to prove the Earth isn't spinning, and then, oh no, it's showing the Earth is spinning. Amazing.
Although, Dapper, I do have to get going.
All right. Well, have a great rest of your day, Doc. I'll continue on with John, and we'll see how this goes. Here we go.
Sounds good. Have a good afternoon,
Should not be
folks.
true.
Bye.
Biblical history is literally true. That would predict it. They have no way to explain this away. Now,
I think biblical history would predict that we would find carbon-14 in these things, except that according to my graph, that doesn't actually always work out. And yeah, okay.
This is also pretty disingenuous. There's nothing about that we would read from biblical history to indicate that Earth's magnetic field should be stronger, that radiocarbon levels should be lower at any specific point in Earth history. The only there's nothing even in modern studies that would tell us that that must have been the case. It could have been the Earth's magnetic field was higher. Nothing predicts that. The only reason you have this is a ex post facto rationalization, right?
Exactly. Yeah, it's not a prediction. It's a post hoc attempt to fit the data as best they can.
Mm-hmm.
Yeah.
Oops.
Oh, what happened? Okay, I'm gonna hit play.
here at the iDino project, they examined a hadrosaur specimen, duckbill dinosaur, Edmontosaurus specimen, Parasaurus specimen, another different hadrosaur, Triceratops hortus. That was the one with the horn.
Did he say Parasaurus?
I didn't make that one out. I'm sorry.
If he did, then that's cool, because Parasaurus is not a dinosaur. It's actually it's like a Paleogene caiman from the area of the Amazon, and it's like the size of like a school bus. It's really, really cool. It had this gigantic jaw. Like, you think, like, oh yeah, alligators have a big jaw. If I scaled it up to the size of a school bus, it would be really big. No, like 4 times bigger than that. The thing is just ridiculous.
And even ancient wood, like axle wood and drumheller wood, supposed to be hundreds of millions of years old, all has carbon-14 in it. And notice it's in those parameters of about 20, usually to 45, 50,000 years at the maximum. It's because not all organisms absorb carbon-14 at the same amount, but nearly the same amount. So it keeps in a relatively tight parameter. Point is, none of these should have any in it.
I'm sorry, we got to stop there. And I want to make this point because this is when people bring this up to me, I go straight to this fact. He's just brushing it off, and he's told you that these all fall in a relatively tight constraint. Let's remind ourselves the half-life of radiocarbon is about 5,730 years, right? And look closely at these ages. I had to go look some others up that they've cited before too. These range from 20,000 to 50,000 years, correct?
Mm-hmm. That's what it looks like to me.
So that's a 30,000 year range. 30,000 divided by 5,730 was just round down, and we'll call about 6. That's a factor of 6. That's to say that the youngest samples here have 6 times as much radiocarbon in them than the oldest samples.
Despite all supposedly being from the same year.
Despite being from the same year, from the same atmosphere, or consuming things that were formed during, at least within decades of that year. Correct?
I would expect all of them to be within each other's mutual margins of error, which they're not. There's yeah. We'll take a drink for just not noticing that.
I would take him seriously, I would take him seriously to the point of we really need to test this. If all of those did fall within uncertainty, or even close, like even within a 2,000 or 3,000 years of each other, but they don't. Not only are they not close to each other, which tells us that none of this radiocarbon that they're measuring here is from the organism itself. Mm-hmm. It tells us there's some other source of radiocarbon that's causing it to be, in this range, but nowhere close from one sample to the next. If you were to look at more papers that have been, or really blog articles that have been published by other organizations trying to radiocarbon date dinosaur bones, even when they take material from the same sample, meaning the same fossil organism, they get ages that differ by 5 to 10,000 years. That's to say, in the same organism, it was a factor of 2 difference, right? I mean, that could not be possible if any of the carbon that you're measuring here came from the organism itself. And if you study, any sort of study the bones themselves, the preserve, what remains of these organisms in detail, you'll find that that's entirely reasonable, because none of the carbon, there will be carbon in these samples. I know the old quip, which is kind of funny, you can't radiocarbon date those, there's no carbon in them. In fact, there is plenty of carbon in a fossilized anything, any kind of fossil, you'll find carbon in it. But none of that carbon came from the organism itself. It's been replaced, countless times over the ages. And that's why it is a fossil now, with the very, very rare exception of, some of these organic compounds have tightly bound with minerals or metals, and they have been preserved, as super trace elements. These are what people think of as soft tissues. It's kind of a misnomer, but these are the sort of soft tissue, ultra preserved things. In that case, maybe you've got some carbon left over from that, but that makes up such a small portion of the sample that whatever radiocarbon you're measuring here has nothing to do, again, with the age of the organism. All this tells you is the varying degree to which you've got mixing in of more recent components, right? Yeah. Which is totally expected. If you have, what do all these fossils have in common? They were found by paleontologists, meaning they were relatively exposed to the surface for many thousands of years, meaning exposed to groundwater, exposed to modern or contemporary organisms with contemporary atmosphere and organic matter and everything else mixed in there. Like, it's not surprising that you would find some amount of radiocarbon in here, especially if you send these off to a lab and you don't tell them what kind of sample you're dealing with, that these are bones from the Jurassic, from the Cretaceous, from the Paleocene, etc. Like, if you don't tell them that, they're not going to apply an appropriate preparation method that would even attempt to isolate carbon that could be from the organism. They're just going to pick up everything in there that got added after the fact.
Okay, but lunar regolith phantasmal terrain brings up a compelling point when they say, but have you considered nuh-uh?
Yes, okay. I have not considered nuh-uh.
Well, I mean, you might want to go back and do some homework then, because... I mean, come on. That's pretty compelling right there.
Unless they're young. Now, this was really proven powerfully at a radiocarbon symposium, international conference in Singapore. And a team of researchers gave a presentation at the 2012 Western Pacific Geophysics meeting in Singapore, August 13 through 17, at which they gave carbon-14 dating results from many bone samples from 8 dinosaur specimens.
Okay.
All gave dates ranging from 22 to 39,000 years, right?
So again, multiple half-lives. So it's the same thing again.
I'm looking at that table of results right now, by the way.
Okay. Well, if he doesn't bring it up, feel free to screen share that if you want to. But I'm going to drink another drink for just multiple half-lives worth of variation from organisms that are supposed to be dying in the same single calendar year on Earth. Which, like,
and this is...
no.
Yeah, the funny thing about this is one of the results table where they did duplicates or triplicates of a single organism, right? So they have a hadrosaur that they sampled something like 6 times here, and they tried to sample, for example, the bone versus the collagen fraction versus they've got bios, the carbonate fraction of bioapatite, the bulk organic fraction of whole bone, the collagen fraction, etc. I mean, it sounds like they're going for everything, and this is something that we would do if we want to. We're working with like woolly mammoth as the example again. You do want to get a radiocarbon date potentially of the bone, the carbonate mineral in the bones, right? Or the bioapatite carbonate fraction versus bulk organic matter versus collagen that you've separated out. And I mean, sometimes those will all give the same age. We wouldn't necessarily expect them to. We would expect the collagen to be the oldest and closest to the real age of the organism, and some of these other components maybe to be artificially younger because they're contaminated or just, they're more susceptible to alteration after the fact. So here they've done the same thing, but it's, again, dishonest because the preparation methods that they would use to separate out collagen in something like a woolly mammoth, they are not going to work here because you have so little collagen. It's such a trace element, and it's degraded collagen that's like bound with other things. So it's not gonna chemically separate. So when they call this a collagen fraction, that's not collagen at all. It's something completely different. It's like the preparation
it's derived from collagen.
Right, and it's a bit of modern atmosphere that mixes in with that and everything else. This has nothing to do with the age of the organism, which is why these results would never have any impact in the field. Like, nobody's going to take you seriously if you present it like this.
Just like they haven't had any effect in the field.
Right.
So Heather Cursorial Angiosperms Coon for $5 says, with microgram sensitivity, your scale will be thrown off by changes in air pressure. Yeah, waving your hand near a scale like that could change it. And that's kind of the same thing that we're talking about when we're talking about these, like microvolt sensors that are picking up just the smallest changes in air conductivity. And yeah, at that level, you do need that kind of precision in order to get these tiny little samples. But when you're at very, very low amounts, it's very hard to distinguish between noise and, say, something else. So, for instance, if you have a microgram scale and you keep it in a vacuum chamber and, you're measuring appropriately sized samples, that microgram sensitivity can be meaningful. But if you're trying to measure something that's already 2 micrograms, it's probably not going to be meaningful, because even in a vacuum chamber, just variations in things like where you put the scale or whether or not it moves or whether or not what little air is in there happens to, have some kind of pressure wave go through it from you just putting something in the test chamber, any of these things could throw it off a bit, right? And so that is one of those things. It seems like creationists don't always get the idea that at the edge of what their measurable range, noise gets more important, especially when you're at that low edge, right? Whatever noise is in the sample, it's going to become more and more important. And that's one of the reasons why, we tend not to bother measuring the carbon age of things that are so old that they really shouldn't be reliably carbon datable.
In the ballpark predicted by creationists, because when they haven't put in the correction factor for the fact that there was less produced to begin with because of the strong magnetic field.
Okay, so the ballpark predicted by creationists, which spans like 6 or so half-lives, and isn't right according to this guy anyway, because even the creationists didn't actually put in that whole like change in how much exact. Okay, so not in the ballpark is what I'm being told here. Smurfs, a name that has no vowels, says, for 69 secs, thank you very much, I would take less than 1.5 million years for the entire baryonic mass of the observable universe in C14 to decay to a single atom. I mean, that seems plausible to me. That if we stopped producing more carbon-14, then all of it would be gone in less than 1.5 million years. Yeah. Although I do like that you went with the actual mega atom instead of going million years. I appreciate that. Thank you very much.
I did the math on that, by the way. Once you get to 250,000 years, you should have 1 times 10 to the minus 25th or so percent of your modern carbon, or the fraction of the modern carbon, which means that would be like 1 atom out of every mole. And a mole of radiocarbon is, you have to take like a big chunk of the atmosphere over a whole continent to get that much radiocarbon. So yeah, I think it's pretty fair to say, well, like at the atomic level, it's probably gone at that point. But that assumes that you've isolated it from any source of radiation or other source of
We're shutting off the influx of carbon-14 completely. Yeah, which we don't have a way to do on Earth. And even if we did, it would probably involve like a solid lead dome over the entire planet, which seems like a bad idea. I don't know about you, but I would rather not have a solid dome of lead over the entire planet.
But again, there shouldn't be any. That's the point. There should be no measurable amount.
But that's
it's always
not
there.
True.
Now, the researchers approached the matter with considerable professionalism, including taking great pains to eliminate contamination with modern carbon as a source of the carbon-14 signal in the bones. The lead presenter was Dr. Thomas Seiler, a German physicist whose PhD is from the Technical University of Munich.
I'm actually not familiar with him, which means I feel like he doesn't do a whole lot of creation stuff, which is odd, because normally, if anyone says the name of a creationist who's done any kind of creation research, I know who it is.
It could have been that he inadvertently participated in this study,
Oh, like yeah, that does happen.
And said, hey, you run a radiocarbon lab. Would you like to collaborate on us? We want to date the different fractions of these fossils. And so, yeah, sure, why not?
Yeah.
I mean, I would say yes, and I wouldn't suspect that it's going to be something like this, where they give me samples from the Jurassic and just not tell me. And then they like throw his name around everywhere, and even now he's he's a PhD in physics, from this university in Munich, and that's great. But it doesn't really matter how experienced or knowledgeable you are. That doesn't change the physics of how the mass spec works. It doesn't change the fact that before you can measure something like a bone, you have to turn it into a pure carbon sample. Right, so you don't just put the bone in the machine. In case you didn't know, if I want to date any bone, including my modern bone, you have to take that and convert it to something like graphite. And that process of converting to graphite always invariably introduces some non-zero amount of radiocarbon. We know that. In fact, that's why there are correction factors to take into account, like the amount of carbon that you're adding during the preparation process. So this is kind of again, disingenuous.
The video of his presentation was up on YouTube at the time of writing this report. It's since been deleted. It got canceled. Anybody?
Ooh, guys, it got canceled. The nefarious they got to them. Take a drink. The only reason videos ever come off of YouTube is because of the nefarious they.
Guess why? Okay, same reason they canceled Trump. They can't stand the truth. Okay.
Oh my goodness. I'll just take another drink for the guy who told verifiably about 30 lies a day in public. Yeah, okay. Goodness. I wasn't trying to make this political. I'm still not trying to make it political, but geez, man. And look, if you ever told me that any politician is a paragon of honesty, I'm going to laugh in your face. Because they all verifiably lie all the time.
Okay. Anyway. All right.
I guess he knows he's proud.
All right.
Even he's taking a drink.
The researchers seem to be associated with Catholic creationist groups. Isn't that awesome? Catholics often believe in an old earth and everything. They, of course, believe the fundamental doctrines of Christianity, deity of Christ, Trinity, virgin birth, literal resurrection, literal return. But they often kind of poo-poo Genesis. So I didn't even realize.
Look, I've known a lot of Catholics in my life. I have a lot of Catholic family. I've never heard a Catholic poo-poo Genesis. Instead, I've known a lot of Catholics who poo-poo this guy's interpretation of Genesis, and those are not the same thing, right? When you come to a text, that text does not have meaning that simply leaps off the page and invades your mind. You bring to that text your various assumptions about it, your prior knowledge of how the world works. You might bring to it things like your understanding of the culture and circumstance under which it was composed. You bring all of these things with you. And together, all of those form the meaning that you're going to take from that. And look, if you want to take that as a literal text telling you what the authors thought actually happened in the world, and then believe that as true, I can't stop you. But I'm also not going to sit here and pretend that you have a monopoly on the meaning of a text, because such a thing cannot exist. Texts mean fundamentally what humans think them to mean. Right? Authorial intent is great, and I'm all for knowing about authorial intent, and I think it can help us interpret what the author meant by the text and what its original intended audience thought of the text. But that has no bearing on what meaning you find in that text. If a Catholic theologian or a Protestant theologian, there's lots of Protestants who are also anti-young earth creationism, or an Eastern Orthodox theologian, or a Maronite, or, Mormon, or whatever, if they come to Genesis, and they come away with a different interpretation of what that means for them and how they're going to fit that into their understanding of the history of the world, you can't say that they're poo-pooing Genesis. It's not how it works. My Unfinished Journey for $5 says, which would be least likely to collapse under its own weight, a dome of ice or a dome of lead? I guess it depends on how thick they are, but I would say a dome of lead. Lead is very soft, very malleable, and I think that it wouldn't have brittle fracture, but I think it would be very hard to make a lead dome that didn't sag under its own weight, essentially, and then eventually collapse in. Whereas ice can actually be quite strong, especially if you mix it with something. Like for a while there was this, I think it was called Icecrete, and it was being researched by militaries during World War II as a cheap alternative to using metal to make boats that were going to be operating in cold waters. And it was very, very strong. It was just not a great idea for lots of other reasons. But they mixed the water with sawdust as like a binding agent to increase its strength, and it was actually very, very strong. So maybe if it were pure ice, it might not work. But I guess it would probably make some kind of ice. And like I think, and I don't remember who said it, but like there are other versions of ice than Ice 1, which is the one that you get in your freezer, that have varying mechanical properties, and I'm sure some of them are stronger than others.
Yeah, ice has some nice deformational plasticity to it as well. That probably less likely to just fracture. And
Baba Ali says, "What if that lead is all one crystal?" Okay, well in that case, then maybe the lead would win. And I guess since it's a miraculous lead canopy that God made as one crystal, I guess I can't say it couldn't be one crystal, because what do I know? So yeah, I guess if we were all one lead crystal, then sure, maybe that would be better. We don't normally talk about the material properties of
the structure of lead, though.
Yeah, I actually don't know what it is. I do know that even when when any metal deforms, usually the individual crystals don't themselves deform much. It's usually the various boundaries between them, and then only on the edges do they ever really have much in the way of breakage. But yeah, I don't know. Yeah, it was Pycrete. This vagary. They wanted to make a giant aircraft carrier out of it. Yeah, that never came to fruition. Although it would have been interesting to be on an aircraft carrier made of ice. I'll tell you what, that 140 degree Fahrenheit room that I was in on an aircraft carrier primarily made out of steel wouldn't have existed on an aircraft carrier made of ice.
I was going to say.
Yeah, that was a fun room to be in. I told that story last week. Go back if you missed it. Turns out, at that temperature, the steel deck burns you if you touch it. It's lots of fun.
Maybe there's a charismatic Catholics, I don't know. But they actually have reported the conference, excuse me, earlier and more vocally than evangelical creationists. One of these reports states that, quote, afterwards, the abstract was removed from the conference website by 2 chairmen because they could not accept the findings, unwilling to challenge the data openly, a public debate, because the only thing they could say was contaminated. They took great pains to rule out contamination.
Okay, but I'm going to take a drink. First of all, it's not just contamination is the only option, although it is a problem. My Infinite Journey for $2 says, ice can it be plausible per @Dapper Dinosaur? I would not go that far. I was asked which was more plausible of 2 very implausible options, and I was able to come up with an answer that I think I stand by. But that does not mean either one is plausible on its own. So, here's the thing, right? A debate is not always necessary in cases like this. There are things that are just wrong, and there's no need to have some big debate, right? We know that carbon dating doesn't work this way. We know that the test chambers do not give the kind of reading that creationists think they do. And sure, I'm sure some guy got invited to talk with what he was about to go on not really being known. Like, remember, this is a conference, right? This isn't actually a paper that's being published in a real peer-reviewed journal. Conferences are where things go to be vetted by a community of your peers before you even bother submitting them, generally speaking. It's the roughest version of your research. Many things presented at conferences do not get published because they're just not sufficiently rigorous, or the results that are being reported don't seem to make sense, or the conclusions don't follow. And ideally what happens if you have that happen to you at a conference presentation is you go back and you rework, you double-check your statistics, you gather more data, you do more experiments, and you come back with a more robust conclusion and methodology and whatnot. But the fact that something was just taken down from a conference because it was nonsense isn't the sign of a big conspiracy.
I would say it's pretty rare that you would have a conference abstract retracted. And this is a different kind of peer review conferences are, but the abstracts published there are not, like, nobody's really reviewing those rigorously, except to make sure you're not publishing, I don't know, a paragraph from an erotic novel in their proceedings or something. Like, that's the level that they're going to screen this out. I think what they removed was a disingenuous reporting of preliminary results, and this absolutely was. For the reasons that we just went over. Like, we know that these ages have nothing to do with the age of the organisms themselves. We know that there are varying high levels of contamination in these samples that have nothing to do with what he just mentioned, the attempts of the lab techs to prevent or remove any contamination. That's not how this works. And that's not what they were referring to when So what's happening here is you can present your scientific results. You don't have to be right. No, but it's not a requirement to be correct when you publish an abstract or a paper for that matter. But your methods must be defendable. Your conclusions must be justified by, from the data that you present. And if you are, giving conclusions that are completely opposite of your data or completely falsified by your data, which these are, then it's not something that should remain in publication if it were a peer-reviewed publication. And in this case, it's kind of a cheap way to get in and try to legitimize your something. It's your pseudoscience. That's really what it is.
And sends facehuggers to brighten your day, Gladstone, which thank you very much. I've got my plush facehugger here. Says, for $5, no one has ever seen a carbon-14 produce anything but carbon-14. Dogs produce dogs, cows produce cows. Nobody has ever seen C14 produce a pineapple. I mean, I agree. I've never seen radioactive active carbon producing a pineapple. Have you, John?
Not yet. I'm waiting.
Well, it would be cool. And for $5, Pillowpunk, half dog, half canine says, so is this lead canopy also transparent and fiber optic, or that's a reference to Carl Baugh, who thinks that the hydrogen in the ice canopy became metallic, even though that's not how metallic hydrogen works. It has to actually be atomic hydrogen. And then, despite the fact that instances of observed metallic hydrogen in labs tend to be very, very opaque, that in fact it was clear, and not just clear, but fiber optic, such that light from the sun was transmitted around the ice canopy to the night side of the Earth, which somehow made it easier and not harder to see the stars, because apparently, according to Carl Baugh, light pollution is good for astronomy, actually. So, feel free to try to make sense of any of that, because I sure can't.
So their one answer has been destroyed. What do they do when they can't answer? They censor. Whether you're on Twitter, whether you're on Facebook, whether you're in a science symposium.
Yeah, this is just definitely like, oh, it's cancel culture. I'm going to take a drink.
Yeah, I mean, I like how he says the best thing we could do is have an open debate. Like, we don't do that. I mean, we have debates in science in the sense of I disagree with the interpretation of this person who published the paper, and then so that just means that in my next paper, I will, present more data, more reason that I think this interpretation is correct or theirs is falsified. Like, that's how you debate in science. You don't stand up at the microphone and yell back and forth at each other. Nobody does that. That's not a good way to resolve questions in science. And I'm sorry.
No, it's not. And you're right. Look, debates like that are for spectacle primarily. And also, sometimes they can help inform non-experts in whatever field about things they might not have known about in that field. That's it. You're not going to convince your opponent in a debate like that, nor is it going to matter at all to the scientific community. But that doesn't make them not fun, and it doesn't make it so that there's no value to anyone in them. But yeah, like, if you think that having a debate about this paper was going to change anyone's mind about anything, it never was. Liz D for $5 says, what weighs more, a 1 trillion pound ice canopy or a 1 trillion pound lead canopy? They wouldn't weigh the same. Also, AIG is a bag of Kent Opens. I will take a drink for that. Thank you very much. All right, here we go.
You get canceled today if you dare to speak the truth.
Oh, no.
This shows they're afraid of it. If they thought they could openly debate it and win, they would. They obviously don't think so.
That's the thing. They do, though. It's just in the literature, right? The limitations of carbon-14 are in the literature. It's well understood. And the fact that you decided to ignore those limitations isn't something to debate, right? It's... I'm trying to think of a good, analogy. And, maybe, let's say you came up with your own version of chess, right? And now you're the best player at that version of chess that has different rules than everyone else's rules of chess. That's not going to make you a grandmaster at chess. I'm sorry. It's not. Because everyone already knows what the rules are, and the fact that you aren't following them, but instead are doing your own thing, doesn't mean that anyone has to debate you about who is a grandmaster at chess. It's not you. If you don't want to ignore the guidelines that have been set up for how to properly do carbon-14 testing and just general, radioisotope dating, which there are many other instances of creationists intentionally doing it wrong, that doesn't mean that they have to debate you. They simply note, oh, hey, you broke the rules that we have set that keep this thing accurate, and then you got inaccurate results. Okay, great. We already knew that.
Let's be clear here too. Like, the rules they're breaking are the basic methods by which they should be reporting this. There's a lot of info missing that would be great to go along with this, and something that if they feel strongly that it's robust, they're welcome to publish it. They can publish it. They don't have. So that we can understand better. We need to know more about the results here. Like, if they're taking a sample which everyone else thinks is tens of millions of years old at the very least, and if they think that there's a orders of magnitude discrepancy in the age here, why aren't they publishing more than just the raw age? And they give us a radiocarbon age and a 2 sigma analytical uncertainty. That's it. Why don't you give us more info about the background readings and the sense of mass resolution and sensitivity on that instrument on that day? What references did you compare it against, and all this other technical information? Why don't you give us some petrographic information showing us like thin sections of what you sampled exactly, so that maybe some elemental scans where we could see where the abundances of carbon were in the sample. Like, there are a million things that would help if you were trying to convince me that there was some significance to these radiocarbon ages, then there are like 12 more things you could do here if you wanted to be serious about it and convince serious people about it. They haven't made any of those attempts. They put it in a very obscure venue to present this, right? And they didn't present it in any of the other conferences. Like, I'm not going to say I shouldn't say that like the Singapore conference was obscure, but it's going to be not read by people who have some familiarity with, say, young Earth creationist movements. And they very well could have tried to present this at the European Geophysical Union or America, Geoscience Union, or the American Geophysical Union, or the Geological Society of America, other types of conferences where they can, say, hey, we've got this discrepancy. And I don't remember them doing that. Like, even before they publish it, and they could put it in a paper form as well. And
John, the food's better in Singapore.
That's true.
Ben, it's very, very good. But I think that's the real motive there, is that they just wanted that better Singaporean food.
Yeah, I mean, like everybody should be able to see here, I hope, that they've taken a route that guaranteed no influence on the community at wide, no interaction with the broader scientific community. It would basically provoked a response like this, where they would,
See, I think the thing is, what they do want is they want to say that they presented this in a formal scientific setting for their audience, which is not workers in the field, right? The audience for young Earth creationists is never the actual wider scientific community that works in a field related to the topic that they're talking about. It is always both, either each other or people who have no idea what's going on, or both, right? That's it. They do not care what you think, right? Because you are under the control of Satan, I'm sorry to say, John. That's the real truth. Okay, so here's what we're going to do. We have a quick thing to read, and we're going to take a quick break so I can refresh my drink, because I am now officially out. And then we'll pick back up, and we are going to probably go a little bit long. We got a couple super chats. The South Geek Insurrection for €5 says, YouTube is a bag of AIGs. Welcome back, Dapper Dinosaur. With a back and a heart. Smash the like button, friends. Yes, please do that. And then My Unfinished Journey for $5 says, radiometric dating doesn't work when you do it wrong on purpose. Correct. All right, so here's what we're going to do. I'm going to take that drink when we get back, because I'm out of my drink. So we're going to take a quick few-minute intermission, and then we'll be back. I'll have a fresh drink. I'll go on my quick, after the intermission, little talk about, how to support the channel. And then we'll be right back to this. And John, feel free to grab yourself a drink or whatever you need to do.
All right. See y'all then.
Okay, and we are back. And we have a lot of gifted memberships. So, first, Roasting a Cold Bones Killer says, "Hail Satan, controller of scientism." Yes, of course. So first I'll take that first drink that I owe you guys already. So here's this is a blackberry hard seltzer. I'm going for some hard seltzer today because it's got a few fewer calories, and yeah, I'm going on the unnamed tavern later on this evening, so I'm trying to keep it a little bit under control. So here's one for that. But then we've also got 10 memberships gifted by Lieutenant Professor Savage Cobra, going to Tiny Pink Penguin, Glenn Collins, Dan Johnson, Michael N, Chowzilla 117, Wayne Gaffney, Elephantian T, I guess, Elephant, I don't know. Fight Mage Studio, Mark Rose, Dick Bauer, and then 5 more from Pibble Punk, Half Dog, Half Canine, going to Binge Thinker, Daniel Bressler, W.S. Wordsman, Zach B. Hancock, Rusty Longshanks, and then 5 more from some weirdo named Dapper Dinosaur, going to Nimaz, Ben Joyner, Pseudodidact, Gotcha Hecht, and Rye. So that's 20. That's almost where I'm just like, no, I'm just going to finish this drink, but we're not quite there. So I'll drink as I go. Here we go. 1. Here's 2. Guys, this channel is almost entirely supported directly by the generosity of my viewers. This channel could not exist at the level that it does, where I'm putting out 1 scripted video a week, 2 live streams. It just wouldn't happen. Here's a couple more. 3. 4.
I feel like I should have something good here. But
should. It's all right. If you are currently not supporting but you want to, we have a whole bunch of great ways that you can help out. That's 5. And 6. One of the greatest ways is the Patreon. It's where I get to keep the most of what you send me. You get early access to my videos. There should be one going up either today or Tuesday. Hopefully another one later on that week, hopefully, but no promises. And you can also get access to a Discord server that's just for the people who support me financially. We have a lot of fun there. Here's a couple more. 7 and 8. If that's not your thing, there's also the join button under this channel. That'll get you a membership to the channel. You'll get the cool symbols after your name. Your name will go green. You'll get the same early access and the same Discord access as you would get if you were on Patreon. Here's 9 and 10. If an annual or a monthly pledge isn't your deal, but you still want to help out, there's a bunch of other ways. There's a merch shelf underneath this video. It's got t-shirts, mugs, phone cases, whatever. If nothing on there actually interests you, you can always click on anything, and it'll bring you to the full merch store. And there's a bunch of other stuff on there that can't go on the merch shelf because there just isn't enough space. Here's 11 and 12. Now, if that's not your thing, there's also an Amazon wish list where you can just brighten my day. Actually, in some cases, you can brighten like my month or something. And there's just a bunch of weird, random stuff on there, right? There's also some stuff for the channel. You know, you want to get me a sound recording booth. They're expensive, but you can. But there's also a bunch of other stuff. There's snacks. There's entertainment stuff. You know, stuff like that. Here's 13 and 14. And yeah, if none of that is right for you, you can't afford to, or you just don't want to support financially, that's okay too. What I ask is that everyone who's supporting financially or not, like my videos, share them, watch a few of my videos in a row. Here's 15 and 16. And then Rosina Cold Bones Keller for $4.99 says, next time get a hard Mountain Dew Baja Blast variety pack for as your hard seltzer. I don't even think that's a thing. But here's 4 more. This is going to close that up. 1, 2, 3, and 4. Okay, well that went from like a full hard seltzer to about half of the hard seltzer in one go.
That's a short half.
Yeah, that was... Whew, I think I'm getting a little bit of brain freeze because I keep these very cold.
Well, while you're doing that, I do want to mention, although he has claimed here that they put this information out and nobody wanted to debate, they just wanted to cancel them. In fact, there have been a number of papers published in peer-reviewed journals dealing specifically with these data.
Oh, no.
Yeah, and the methods that they used, the results that they had, the best way to interpret them, and those are available. I mean, and anybody can go find them on Google Scholar and download the manuscripts. So I'd encourage you to do so. I mean, there's one just from 4 years ago, Philip Center et al. 2020, who did, go painstakingly through these data, and they took them a lot more seriously than they deserve to be taken. But it is a very informative paper, even if it just helps you better understand how radiocarbon works and the type of data that we're dealing with.
Hey, send me a link to that paper, and I will put it in the description of this video later. I also want to point out, hey, we are well past halfway to getting a new special Dapper avatar on the channel. So, if you guys want to have another Dapper, we're on track to make it possible. Not another Dapper, but a special avatar, right? Like Feather Dapper or the Cyber Dapper or the Dapper Mech. I'm probably not going to put Clay or Mickey Dapper on there because they were both reused very recently, but still. Here we go.
This is very, very powerful evidence. So we have all this mosaic of evidence of all kinds, all up and down the geological record, all up and down the fossil record. It's a mountain of evidence. Cries out.
You know what my favorite response whenever a creationist says that there's a mountain of evidence is to point to El Capitan in Texas, a literal mountain that's made out of this substance called coral. And it's too much coral to fit into the entirety of the young Earth timeline at all. And it's just right there, a literal mountain made of evidence against young Earth creationism. You know how many creationists I've ever heard talk about El Capitan in Texas? None. I've never even heard one mention it.
No, not many.
And yes, Pillowpunk, I know the history of Mountain Dew, or it's an old-timey term for moonshine, and that also the current thing that we think of as Mountain Dew was originally made as a mixer for alcohol and whatnot. I just don't know that there's pre-made Baja Blast seltzer with alcohol in it. I've never seen it. It would be interesting. So,
I think we should answer his question here. What is the likelihood that all of these would exist?
So I guess it depends on exactly what he means. What is the chances that the actual evidence that we really do have of things like fossilized protein remnants and non-perfect test chambers for mass spectrometry? Very high. The chances of that are very high. The chances of us having perfectly preserved soft tissue that's fresh off the bone that you could, turn into a dino steak, which seems to be what he's implying, or that we have, copious amounts of carbon-14 in dinosaur bones that don't even fit into his timeline, and that are actually, original to the organism that died. I can't say it's zero, but it's close enough that I'm not really going to make the distinction. What do you think? Do you agree with my assessment?
I'm curious to see how he presents them. I think we should make an assessment.
Okay, here we go.
That these are only thousands of years old, just like the Bible indicated.
Well, the chances are basically zero.
Hidden for thousands of years, revealed in these last days. And if we can just get this out to the public consciousness, it will be the utter stake through the heart of Darwin's theory. The last nail in the coffin.
I always love it when they're like, these are the last days, you better repent now. It's like, dude, people have been saying that for such a long time. And like, at this point, everyone who's like, these are the last days, Jesus is coming tomorrow, you're all just the boy who cried wolf, right? Like, I don't want this to be a big theological thing, but look, there are Christian theologies that don't involve you needing to have an imminent end-of-the-world threat. You could just adopt one, right? And sure, you can argue that's just a response to the failure of the prophecy of Jesus that the end would be coming before that one generation passed away. I don't care. I'm not here to tell you what your Christian theology should be like. I am here to tell you that probably shouldn't be one that is demonstrably false, because that seems like a bad idea. Rosina, Cold Bones Keller for $4.99 says, I would never ever joke about Hard Mountain Dew Baja Blast. It's real. Proof on Discord. Oh my goodness, there's proof on Discord. Hold up. This is something hardmountaindew.com is a thing. I shouldn't have clicked there, right there. Must be 20. Yeah, I'm 21. Let me in. Oh my goodness. It is true. Hard Mountain Dew Baja Blast has a cartoon shark on it.
Oh god.
I'm gonna
This
have
sounds
to look
extremely
into. I'm gonna have to look into this. All right. Hey, you know what? Fair enough. And also, by bringing it up on the main screen accidentally, I'll take a drink for Dapper's a professional.
I'm sorry. This sounds like the awkward American teenagers version of schnapps.
Yeah. Well, yeah. Look. Although I gotta say, my dad used to do performances of Handel's Messiah with various, like, basically pickup choirs, because that's a thing. Like, you do Handel's Messiah around Christmas time, which is a group that you assemble specifically for that purpose. And he was the guy who always handed out little nip bottles of schnapps to the entire choir. It was always peppermint schnapps, and he would bring like a case of them or something with him to go do this Handel's Messiah. And he was just like, "Here you go. Here's some peppermint schnapps."
So points to remember in conclusion.
Okay.
Soft tissue and proteins are acknowledged in many scientific publications as genuine, over 50 to date.
So again, now this is something we talked about the last few times, right? Because this is our third or fourth episode about this guy. And I know you weren't here, John, so sorry about that. But it is true that there are fossilized soft tissues, but they're not soft tissues like you think of them, right? Like, you can pinch your skin and it's all stretchy and, whatever. And, like, you know that you've got, like, mucus tissues and muscles and whatnot, and they're all, like, goopy and wet and things, right? But that's not what's being found in dinosaur fossils. What's actually being found are the broken down molecular remnants of such things. You're not going to be able to get a Triceratops steak ever. Yeah. No one's going to chop off, a flank steak of Triceratops. It's just not going to happen.
Yeah.
So, yeah.
And this here we can also make a hypothesis. And keep in mind, when we do find these so-called soft tissues and proteins, we find them in such trace amounts that you have to start with like a big bulk sample and dissolve it down to nothing just to get tiny microscopic remnants of this stuff. It's not abundant throughout the fossil, which we would expect it to be if the age of those fossils were in the thousands of years, but they're not.
Right. They should be the same essentially as the same age as like ground sloth fossils that we find in all over North and South America, where you can find.
They should be only 700 to 1,000 years older than the woolly mammoth fossils and other great megafauna from the last glacial period. So this is one point for conventional geology and one point of falsification for the flood geology.
Acknowledge it as real. No experimental data exists showing how these could survive thermodynamic breakdown and ground radiation for millions of years.
I just sent you the experimental data.
Oh, good. I will make sure that I have that. Did you send it on Twitter?
Yeah.
Okay. Well, that'll be in the description shortly after this stream concludes, everybody. So if you're watching this in the future, or check the description now. And if you're watching it live, check the description, a few minutes after we stop being on air. Well, okay, like, give me an hour. I don't know how efficient I'm going to be, right? But, so, this is another thing that he said before, and I do want to reiterate. Thermodynamic breakdown isn't a thing, right? Atoms break down as a result, molecules break down as a result of identifiable processes. So you can say, like, okay, radiation entering the bone from, radioactive isotopes, that might break chemical bonds. Yes, that's an actual process that we can identify, right? Being heated up so that you're now above the temperature at which spontaneous chemical interactions are going to start happening that break down the molecule, right? Like protein denaturing as a result of heating, which is what happens to your food when you cook it. That's a particular process. If you have a relatively stable or even metastable molecule, that's just in existence, and you don't do anything to it, it's not just going to decay because thermodynamics. That's not how anything works. If something's already stable under its current conditions, and those conditions don't change, it doesn't just decay. Something has to happen. But he's got this idea in his mind that the second law of thermodynamics means that molecules just break down spontaneously. They don't. That's not really how it works.
Yeah, what is breaking down here, we've got like the deamination of certain proteins, including like DNA and such, or DNA molecules. And so anything like this is going to break down because it's unstable at these kind of conditions. Generally, it breaks down to the point where it bonds with something else and then becomes stable.
Right. And
it's those configurations that we do find in trace remnants in some of these fossils. So we find pretty much what we would expect to find if these fossils were in fact the age that we think they were and survived the conditions that we think that they do based on independent evidence. So this is again one point of falsification for young creationism.
Exactly. Those heme-derived porphyrins that have been reported in a few different studies, they're not hemoglobin. They're the stable thing that hemoglobin turns into after millions of years. So of course we expect to still see it.
They believe it can. They have no experiments, which is real science, to back up their belief.
Oh, well, that's just a lie, so take a drink.
Yeah.
We've already gone over why it's a lie and what experiments in previous episodes.
There is no legitimate explanation of carbon-14 in dinosaur bones or in coal or oil or wood that's supposed to be hundreds of millions of years old. It simply should not be there.
That is the legitimate explanation, that they are that old.
Mm-hmm. Yeah.
That explains the results perfectly.
Yeah. We'll take a drink for that one, too. In part because I'm thirsty.
And I think we've pointed out that this does thoroughly falsify, like their results from the radiocarbon dating attempts of these do falsify their model thoroughly.
Yeah, at least his model. I don't know who else shares his exact model, but like, it certainly doesn't comport with what he's saying. And I don't know the exact carbon history that all creationists are going with. But it's certainly not what, like, his model does not work with it.
Based on the graph that he showed, I think we found that if you could date any kind of material from the age of Christ, then it should give an apparent radiocarbon age of 7,700 years. I did the math on that one, according to what he showed on that graph.
Right.
We know that is not the case. We have stuff from the Roman era that dates about 2,000 years, like it should.
And the great thing about the Roman era is that the dates that we use today share continuity that's unbroken all the way back to the Roman era. Now, granted, we've changed our numbering systems, but that was in a system in which we knew the old numbers and we had updated them to some new count, and we can trace all of those numbers through in not just archaeological or carbon dating techniques, but actually in historical records, like written down things where people in the current year that it was when they were writing noted what year it was. And we can trace all of this all the way through. So it's not like it's a big question as to when things like, Emperor Constantine coming to power and becoming the final sole emperor of the entire Roman Empire. Like, we know when that happened. Do we know exactly when the crucifixion happened? No, but we know when historical events around it happened. And so when we carbon date things and they correspond to the historical record, we know his model can't work. Because if we can find some coin that says it's from the reign of Caligula, and we know when Caligula reigned for multiple reasons, including just people writing it down, and we can carbon date things from the same archaeological stratum as this coin from the reign of Emperor Caligula, well, guess what we have? An independent confirmation of carbon dating at least that far back. But his method would counter-indicate that idea, that we should get a different carbon date. Well, sorry, buddy.
And there's no refutation of radiogenic helium in basic granitic rocks. Now, that's evidence that the regular radioactive decay, like uranium, thorium, uranium, lead, neodymium, samarium, etc., that these decayed rapidly in the past. They decay slowly now, but initially they decayed rapidly, and they left physical evidence in the form of radiogenic helium. Don't have time to go into that, but it's covered in my DVD out there, Scientific Evidence for Young.
Well, we do have time for that. So, John, what do you think?
I was just going to say, unfortunately, we don't have time for that either. But
oh no,
I mean that's a whole nother can of worms, right? Like you just opened up a big box of discussion there. The short version is just that's also false, and for the same reasons, they're using fishy reporting that's only provoking a sort of dismissal from the part of other people, like other serious geologists in the field, and we're dismissing it because their methods are just garbage, here. The results that they showed, first of all, if we took them at face value, all the measurements and the modeling that they did at face value, it does show it would show an extraordinary result that apparently contradicts the known timeline of those rocks. So in a case like that, if you have some evidence that gives a strong conclusion that differs completely with the prevailing thought, the first thing or the least you could do is go and repeat the experiment. And that's one thing they never ever did. Like they measured the amount of helium in this, and then they measured the amount of helium diffusivity in the zircons that they took this from, but they measured those in different decades, and not on machinery that had the sensitivity required to measure those accurately. But even if they did, I would like them to just do it again. Like, you can go back and there's plenty of rock you can take this from. It's not the only place in the world where you can find these basement rocks. I mean, you should be getting this same result again and again and again and again. And if you did that, people would maybe take you seriously, because that would be an extraordinary result. And they never tried to repeat this. Like, they spent 20 years plus, Humphreys did, trying to convince everybody that the original decades-old analyses were correct, right? And that doesn't even get to the point of like, well, at this point, I'm just assuming his data and his model is fine, and it's absolutely not fine for many reasons. But the first thing you should point out if somebody brings this up is, why didn't they just do this again? Like, we have this radiometric dating method, this uranium, thorium, helium method. And what Humphreys and others did there, what he's talking about, they took that method and kind of ran it in reverse and said, like, well, if all of this helium appeared at once, based on the diffusivity, like, how old could these zircons be? They didn't have like direct evidence that all this radioactivity happened at once.
We know it almost certainly didn't happen at once, because that's not how it normally works.
You know how we know it didn't happen at once?
How?
Because the zircons still exist with all their bonds intact.
Whereas they would have melted had it all happened at once.
Yeah, they'd be plasma.
Right.
But the thing is, we have this method, uranium, thorium, helium, and that is where we take the uranium, thorium-based age of the mineral and compare it to like the amount of helium that is still stuck and bound within the crystal lattice. This is helium that's been produced by radio, like the alpha decay over the history of this mineral, and we use that to find out not the age of the mineral itself, but the age of the point at which it was last below a certain temperature, right? Mm-hmm. And like, how long has it been since this mineral was about 180 or 200 degrees centigrade? If we know that, then we know, for example, how fast this rock has uplifted and then eroded off the top, to expose it to the surface. Like, it had to reach those temperatures, it had to be buried down quite a bit. So it is a very useful method, but it's very common. The point is, we have thousands and thousands of data points using this method. All of them give us results that show there is just the right amount of helium you would expect if these rocks have been buried for several millions or tens of millions of years and slowly were exposed to the surface due to erosion and uplift, right? All of those flatly contradict what they're proposing here, in my opinion. And meanwhile, they've never tried to repeat this experiment. Why?
Well, I can tell you why. It's because the only way to get it to work would almost certainly be to misapply various techniques in obvious ways, and because it remains rhetorically useful for their target audience, which is not you or me. It is the people who are in this church who think the idea that, like, Trump is being canceled while currently being broadcast on every major news platform in the world is a reasonable thing to say. Mm-hmm. That's their target audience. The people who are so out of touch with reality that they think that the guy whose court hallway speeches are being broadcast daily is the one who's being censored. So.
Yeah, I'll just keep it at that because this already just
fair.
contradicts everything there. The other thing to point out is when they estimated the rate at which helium is diffusing out of the crystal, the two major mistakes they made there was one, the geometry of the zircon they were simulating. They used a very simplified geometry that didn't look anything like a zircon, and resulted in a diffusion rate that's pretty much unrealistic.
Yeah.
So yeah, models are good, right? But models are only good insofar as they're replicating what's happening in reality. We use models to say forecast tomorrow's weather, right? And that works because we can accurately simulate the geometry of the Earth and as it rotates and the atmosphere and how that's all moving around. If we were to put in our model that Earth were a cube, just to simplify the math, I mean, you simplify the math like Humphreys did, but it's don't be surprised when your forecast turns out to be very wrong.
There's a level of simplification that's necessary to just get the model to be calculable in the first place. But once it goes too far, it stops being a representative of reality in any useful way. And you gotta balance between those two, right? Like realism versus usability. Because if you wanted to model the entire universe exactly as it is, you would just have to build a whole other universe, at which point, what are you doing? What's the point? But on the other hand, if it's so simple that it doesn't accurately reflect what you're actually trying to predict, then also, again, what's the point? I'm going to hit play.
Age of the Earth. So even standard radioisotope decay actually argues from a young Earth, because we have the evidence that it wasn't slow.
Just room for that one.
It was actually fast. No credible explanation for an evolutionary origin of the first species, the first cell. By the way, if you...
BC is not the singular of species. Species is already the singular of species. Specie is a word that means money in the form of coin as opposed to bills. Just putting that out there. If you type in specie into your word processor, it won't get the red squiggles because it's a real word. It's just not the singular form of species. And also, no credible explanation for the origin of the first species, if I'm going to correct his English here. Basically, what he's complaining is that we don't have a full account of the origin of life. Okay? Cool. Other than to say, okay, great, I don't know what else to say to that. Because the thing is, all he's saying there is certain aspects of science have not figured out everything. Which, yeah, we all know that. That science has not answered that particular question to his satisfaction is not evidence that the Earth is 6,000 years old and common ancestry doesn't extend ever any farther back than the family level. Those things do not follow in the least. So remember, he is trying to use this as an argument in favor of young Earth creationism. At best, you could maybe argue that might help out an intelligent design broad argument, even though it doesn't, because even then, it's still just an argument from ignorance. So, at best, even if we ignore the fact that it's an argument from ignorance, all it does is get you to a sort of bland, intelligent design with an old Earth and still common ancestry for all the subsequent species.
Right.
But it doesn't even get you there, because again, it is an argument from ignorance.
You can prove that, you get $10 million. Used to be $1 million, and they upped the ante to $10 million if you could prove life can evolve from non-living matter.
Who's putting this money up? I have no idea what he's talking about. Who's offering this prize?
Nobody's collected it, because you can't. It is mathematically, chemically, physically, thermodynamically impossible.
Well, that will be news to all the origin of life researchers, who all seem to think that it is in fact possible, and who are all making progress towards answering questions about how life could arise from non-life. I won't use evolve, because in that context, it's not technically accurate, but whatever.
Only coming from the hand of God, of course. All right.
Okay, look, dude, if you're going to complain that scientists don't have a great explanation for how life originated yet, which, I'll be fair, they don't really, saying the hand of God doesn't solve that problem. The hand of God isn't something I can measure in a lab, right? It doesn't help me with science. It doesn't propose new areas of research. It's not testable. It's not falsifiable. It's just as good as saying a wizard did it in terms of science. Now, if you have a theological commitment to the existence of God and his hand and the role of the creation of life, I'm not going to complain about that, right? And look, if you want to say that your reasons for believing in God are various philosophical arguments for the existence of God that have been put forth by theist philosophers, I'm also not going to have that argument because I don't know enough about any of those arguments to really have that argument. But if you want to propose this as the scientific mechanism for the origin of life, then you're going to have to try to find a way to quantify the hand of God. Good luck. I want to know, how much does the hand of God weigh? I don't know. Yeah.
No credible explanation of the lack of ancestors and transitions throughout the fossil record. Right.
Yeah, the credible explanation there is I just got lazy and stopped searching through the paleontological literature.
Yeah, we're going to take a drink. We're going to take a drink because what's playing, you can't see it here, but what's playing on screen for everyone in the audience is, in fact, my transitional species slideshow. So feel free to get your Vishanti emojis in here to simulate what it would be like if she were here yodeling. Because I won't subject you to my attempts at yodeling. I won't even accept...
I'm sitting here now in like the mecca of yodeling. But it's not something I could even dare attempt here. No. Although we've got some neighbors who do practice it, and
interesting.
Have you ever had a neighbor who practiced yodeling throughout the night?
Not that I'm aware of, no. I feel like I would be aware of if I did.
I mean, I've got nobody to share that with.
Oh, I'm sorry. I did sing in a choir for a little while, but I was also a tenor, and like the tenor part was always like, hey, you're going to change notes like 4 times over the course of this entire song. Like, okay, cool, thanks. DM, Original Institute Academic Excavation Wing for $2 says, that's $10 million in escrow, right? Yeah, there's the other thing is this $10 million in an escrow account that we could actually check to verify that it exists? Or is it just some empty promise some guy made? Because it sounds like the Kent Hovind challenge, right? For a while, Kent Hovind had this $250,000, if I remember correctly, challenge that was like, prove or provide, the way he framed it was provide evidence for evolution. But when you actually read the fine print of what actually the challenge entails, it was that you had to prove that God couldn't have done it, which is not how it was sold. And also, the only person who was the final arbiter of whether or not you had met the challenge criteria was Kent. So of course no one collected it, because it wasn't an honest challenge. Just like all the Flurf challenges, the second law of Flurf. Flurf challenges are always fake. I would make a corollary that extends to young Earth creationists.
Mm-hmm.
Where there should be obvious proof of Darwinian evolution, the gaps are systematic. Darwin himself said this was the most obvious and serious objection to his theory. It's only gotten worse since he published his book in 1859.
Yeah, we certainly don't have any great transitional series for, like, you know, land-dwelling artiodactyls into cetaceans, or Miocene apes to humans, or just basically all of Ceratopsidae. Excellent fossil record. We don't have chrono species in the genus Thalassocnus that shows us the step-by-step, an almost generation-by-generation transition from what was basically a barely aquatic sloth to a fully, well, very much more aquatic sloth. Philipunk, half dog, half canine for $5 says, similarly, you can get a cash prize for proving evolution to Kent Hovind. All you gotta do is, and you're bringing it up as I'm typing. Oh, well. Sorry. Yeah, that's one of the problems with the delay and everything. And yeah, all these challenges are pretty much fake.
And therefore, there is no proof that the biblical account of origins is not, therefore, superior to the evolutionary narrative.
Just drink. It's fine. We've already gone over it ad nauseum.
Yeah. Oh no.
Oh yeah. Mary Schweitzer's things that look like blood cells. I am wondering, now that he said that that's his conclusion, where else is he going? Because the video is not over. Is he going to start preaching? Because if he starts preaching, that's it. We're out of here. I look.
Well, he's going to give us some testimony from Mary Schweitzer, who. Okay. You know, that's the best route always to take, and that's what I like to do when I cite papers. I like to present, cite the paper for the opposite point of what the authors were making.
Mm-hmm. Obviously.
And yeah.
Now, in conclusion, we see this evidence of blood.
In conclusion, for the next time, because he's already said in conclusion once.
Cells still intact in dinosaurs supposedly 65 to 220 million years old.
Nope. still those are only morphologically consistent with blood cells. They have not been found to be blood cells. There's a difference. Take a drink.
And it cries out with a voice of truth. You know, the Bible has a teaching starting in Genesis that blood has a mystical or spiritual voice, that it speaks, and when it speaks the truth in the face of the lie. Where do we first see this? We see it in Genesis 4:10, where Cain slew Abel, the first murder in history.
I'm going to skip ahead and see if this is still just preaching, because I don't really care about the Bible in what seems like a very obvious metaphor, saying the voice of your brother's blood cries out from the ground to me. Like, I don't see... Unless you actually think that Abel's blood was like, hey God, I got murdered, then this is obviously a metaphor.
Well, you know, a lot of these presentations and most of AIG is just an exercise in misreading Genesis, right?
Oh, yeah. All right, we'll see where that is.
Against you.
Nope, still...
Unimpeachable. This is before our God day and night. Kind. They were created by God.
Kinds of words.
Oh, and that's just whatever the pastor guy is selling some books. Which means, I guess we got... I thought there was going to be a little bit more to that. I thought he might have a little bit more for us, but that's okay. That's where it is. So, I hope everyone has had fun. John, did you have fun?
I had something. That was it was interesting. I'm glad we made it through the whole video. That was pretty impressive.
Well, we did take about an extra 15 minutes or so. So, you know, it's a little bit longer. That's also why it was late with the break.
I feel like I could apply for a job, though, for their writing team. Just it's not like we couldn't anticipate every point they were going to bring up.
Well, yeah, I mean, you never can. And that's one of the things is, like, the live streams are always the sort of, like, what are they going to say next? You got to be on your toes. The careful, we check every source and we go in depth, that's for the scripted videos. Which actually, I think you in fact have been helping me out with one of my more recent scripted videos. So thank you very much for that.
Yeah, no problem.
Yeah. So, all right, everybody, let's take a look. Well, John, do you have anything coming up that you want people to know about? Any place they can find you that you want them to know about? Anything like that?
You know, I actually did start making videos, recording them. They're not up yet, but I would really like to get consistent on that. The goal is to maybe to do some, you know, whatever explained in 4 difficulties kind of videos. I've already started working on one for Radiocarbon, where we'll go through the technique and how it works in 4 levels of difficulty, so that by the time you get to the end, you know, we'll get into more of the gritty details about these data and what they mean and what the real uses for radiocarbon are. You know, of course, I'll give some talking about the climate system and geology, and maybe have fun and go into, you know, flood geology discussions too. But and nothing at the moment that's up that I would say, hey, go and subscribe to that. But I'm happy if in the future, if you'll look out for it, and hopefully I'll have something to share.
Absolutely.
Yeah.
All right, so let's take a look at what's coming up on the channel. So on Tuesday, the plan is Jackson with Jackson. That's me and Jackson Wheat. We're going to be taking a look at the claims of Charles Jackson, back from when Charles Jackson was a young whippersnapper who had a mustache that looks like it came out of an adult film from the year 1976. That's what we'll be looking at on Tuesday. That will be at 6 p.m. Pacific, 9 p.m. Eastern. Then on Thursday, Chemistry is Hard, which is going to be a Mud Fossil University and Living Volcanoes, Part 1. It's only a 2-part series. Roger from Mud Fossil University is going to tell us how, in fact, volcanoes are just the exit end of the digestive system of gigantic creatures. So, yep, that's a thing. John, do you have a quick 1-sentence take on whether or not volcanoes might actually be the anuses of gigantic biological entities?
I'm gonna go with nuh-uh.
Okay. Then I'm actually releasing another. That's going to be at noon Pacific, 3 p.m. Eastern. Then the very next day, I'm having an extra video this week, which is debate question exclamation point question mark, dumpster fire question mark exclamation point, in which it is basically a mirror of my discussion with Rob Groen and Jackson Wheat. Rob Groen is I've been good all video. He's an ass, and we point that out more or less to his face eventually during this whole thing. And so it was a pretty wild discussion as far as my discussions with creationists go, but that's okay. And that is coming out on Friday, basically because it's been a bit of a rough month, and I could use an extra video this month. So there you go. That's why it's coming out a little bit early. And then on Saturday, which should be the 1st of June, I want to say. Yep. The plan is to have another Dapper Reacts, but I don't know what it's going to be because we just finished the current video for Dapper Reacts. So who knows? And that will also be at noon Pacific, 3 p.m. Eastern. I hope to see everyone here for Tuesday. I hope you have a wonderful rest of your weekend. Stay safe out there. And we're getting out of here. Bye, everybody.
Bye-bye.
Hey, before you leave, I just want to take a second to thank my patrons and channel members, especially those pledging $20 or above. Benthoven, Thoravara, Tapioca Weasel, Whispers, Eleron Teller, Horseflesh, Ian Chen, Kelvin Brostek Van Manen, Landon Knoll, Mabdy Babdy, Sphincter of Doom, Wallace, John Ackerman, Eta V, and Strawberry Vein. It's because of my channel members and patrons whom you're seeing on screen that this channel can stay afloat. Without you, it would all shut down. If you want to join the team, there's a link to join the channel below this video, and there's a link to join the Patreon in the description. On the Patreon, you can get a 10% discount for pledging annually, and either way, you get early access to virtually all of my scripted videos, often 3 to 5 months before they come out for the general public. Thanks for watching.